Okay. Good evening, everyone. So, in this session, I'll discuss about what are the different programming things that you have to do in this term. Like there will be a set of programming weeks. So those weeks only have this programming assessments and no lecture contents in that. So before doing into like solving those exercises, we should know the basics of programming and how we program in this embedded systems and these devices. So I'll just describe about different terminologies that you should know before coding into this uh, systems and what are the things where you can look for when you have doubts. What are the different types of programming tools that are available, what are the different IDEs, frameworks, and a lot about that. Okay, so I'll give you a brief introduction on what are these things, the tools that we'll be using with this course, and yeah, so that's about today's session. So each week you will be having a theory session and a programming session where you will be introduced to like do some programming, doing some programming in simulations, such like that, things like that, right? Okay, okay. So yeah, let me share my screen. Hope my screen is visible, right? Okay. First we'll discuss about tools and IDEs, right? So what are the different tools that we have? So the one thing, so there are uh, different tools that you can use. So one is this, there are different tools. One is like web-based, web-based tools, simulators and IDEs. So one thing that we will do here most is like this one. We'll use a tool called Walkme, right? And let's just come back to other tools, IDEs. So what are IDEs? Integrated Development Environments. So these are like so if you have, there are different IDEs called as the Arduino IDE, and there is this VS Code, the IDE that I am currently open. This is a like most common IDE that people use for different purposes. Visual Studio Code. So these are IDEs are the uh, software that we use to write code in tools for writing and debugging code. That's what we call IDE. So it has connect tools for like multiple tools for managing code and doing other related tasks such that running your code, seeing the output, and uploading the code to the system. Those kind of tasks this IDE can do. And there is some other IDE called STMQ, so STMQ IDE. So right. So so ST is like ST Microelectronics. That's a company, and Arduino is also a company. Visual Studio Code, this is by the Microsoft. The maintainer of Visual Studio Code is Microsoft. So it's like different IDEs where you can write code and run. So this is one thing that you want to know. And the thing is that what are the different frameworks? And also there are like command line based tools that you have. Uh, so these are like certain tools that you can use to this IDE provides a GUI based way to do tasks like compiling, building, uploading code, and things like that. Similarly, there are like equivalent IDEs which can do the same thing like building, compiling the code to a particular system and things like that. That can be done with some command line tools also. One is Arduino Glide. So this is like a command line tool with like without using the Arduino IDE, you can use your preferred IDE and use this command line to compile, upload code like that. There is this platform IO. Uh, there is something called as platform IO, which also offers a slide. This also helps for compiling and run the code. So this platform IO, the slide will have a set of tools that help you configure a project and do things for a certain project like that. VS Code also has like extensions for VS Code with extensions. So I think we discussed it in a separate uh, whole thing itself. So VS Code is kind of a flexible environment for developing code. So people use VS Code for developing lots of different things, and we can also do that for embedded systems development, right? So VS Code comes with this extensible architecture where you can install the extensions for whatever languages or things you need. So there are certain extensions that you can use with VS Code. So there is something called as platform IO. This platform IO can be also used as a extension in VS Code. So that provides you a GUI-based way to run things. So this IDE, you can install it. So this will give you a UI-based project setting up instead of a command line-based thing. So yeah, that's platform IO extension is there. Extension, and then there is this WalkMe extension is also there. So WalkMe extension. So what WalkMe does is like doing simulations, right? So let's just go. So this WalkMe extension also there. You can use that to set it up. So this simulation you can do offline itself. So that gives that like offline, not offline, out of the browser with your local compiled code. So I'll also explain what WalkMe is and what are the things that you can do in WalkMe and what are the different things that you can do with it and how you can go about solving the programming process. So most of the programming exercises that we give are like can be done with WalkMe itself. So I'll also introduce to WalkMe that guess what? These are the two extensions. And sometimes I guess there is one more extension, I guess. Something that, yeah, which wave trace extension we use for theme. So it's like for viewing digital signals. So while we are dealing with the timers and other things, we generate this pulses like digital signals. So to look at the timing of different signals, we use this extension to do that in VS Code itself. Right? So these are like different extensions that we might use here. Okay. So now let's go back to WalkMe and what can be done in WalkMe. So WalkMe comes in different shapes. So one is the WalkMe online platform, and a WalkMe VS Code extension. And also WalkMe comes as a command line also that you might not be using much. Right? Let's see how WalkMe looks like, right? So this is the WalkMe site, walkme.com. So this is like a different, you can simulate different development boards like this. What you can do is you can create a project. There are different sample projects that are around there. You can take a look at that also. And also starting from scratch. You've got a board here and you can create connections with different components. So there are different components there. So what are the things you got in WalkMe? Different development boards are there. and different components like sensors, uh, actuators, control things, and display utilities. Like for example, you can see whole lots of things like this. Uh, these are some basic utilities like push button, or these are like controllers you can call, and certain input devices. These are certain specific input devices, sensors, some breadboard for connections, and logic gates if you want to work with that. And the custom chips, you can even have custom chips inside these things, and many things are there. All right, these are the things that you have, and different boards that you can work with. All right. Now let's talk about some more things like yeah, what else we can do, and a code editor, right? So code editor, you can have different files. The sketch.ino is the default file in an Arduino framework. So there are like what language you will be writing code in? Usually C or C++ in embedded systems, right? So most of the code that you write will be in C or C++. Uh, and let's talk about different frameworks also. Okay, different programming frameworks. So like there are like multiple programming frameworks are there. So the first one that we will be using is like the bare metal. So this is like writing code, knowing exactly what the registers are, and then writing upon register level code to manipulate the values in the registers to control the systems. So bare metal code, you can think of manipulating the registers directly without any libraries or frameworks like that. So this is like bare metal, right? And then you have like system specific low level drivers or low level programming frameworks. So for example, in uh, so we will be learning something like this uh, in Arduino boards. So you have this. Yeah, so this called yeah. So you have like this AVR based programming, and then in Arduino you have, and then there is this STM boards. So here you can use, there is something called HAL, like hardware abstraction layer. This uses like very minimal functionalities to work with it, some basic functions that you can work upon. So that there goes HAL. HAL is kind of more like a high level framework, so we can put that for later. So here you have something called as low level in STM. STM boards you have something called as this. There are different boards if you look here. So there are different boards in which you can code actually. So yes, you see this. So Arduino is kind of a manufacturer you can think of. They manufacture these boards, and then there is this STM. So they manufacture these kind of boards here. So this is this STM Nucleo board. So this is also a development board. So you see, this is a development board that we call. So this is the microcontroller that is present here in this one. So the chip that is present inside this development board is the microcontroller. So let's talk about this also. Also something that you might want to know. Uh, let's break it down. Yes. So here we can have where is this? Then the breakout circuit. So this is what we call a breakout board. So this is microcontroller has different pins associated with it. And this breakout board extends that connections to a easily connectable interface. So you can plug and play different components, try out different things in that. So this is what we call the development board, right? So this other part is what we call a breakout board, and that is connected to the microcontroller. So there are different development boards for us to connect different components and things like that. Even the sensors and other things come out with a breakout code that you usually do with these development devices, and that you can easily connect to the systems. Okay, so these are the two things that you have. There are these things like different manufacturers, and Arduino is one of that. ST Microelectronics, STM, and then there is this ESP Expressif uh, uh, company manufacturer. The CSP models are like created by Expressif, Expressif Systems. And then there is Raspberry Pi, this development board. I think you might have come across this before. Raspberry Pi, this Raspberry Pi Foundation, the one who develops these kind of boards. Raspberry Pi. So these are different manufacturers that you have in like the general systems. So mostly these Arduino boards, they come with a very simple chip, come with a chip called Atmega chip. So this is like a kind of very simple one. This chip that you see is kind of very big, right? So this is like very less sophisticated chip compared to the other chips that are coming. Where ST microcontroller has like more sophisticated chips that can do like they come up with this ARM chips so that are like capable of processing many things well compared to simple Arduino Atmega chips, right? Okay. So so far I have told many things, right? So let me complete this one. So there is this HAL, and then there is this Arduino framework is there. So Arduino framework uses the .ini files, and here you can use like setups like C files you can use here. That is fine. You will be using a main.c here. While using AVR, you will write your whole code with the .c files, and here you will have similarly .c files. Sometimes you can also write code with CPP, such as depending upon whatever you want. Manipulating the So AVR libs is like set of libraries that you can import. So like a very minimal libraries which only have like code definitions and the register macros. For example, if you want to take a look on that register, it has the register address predefined in some header file so that you can quickly access that using the name. Those are like very minimal libraries that you have. These are like very structured libraries, like high level libraries that you can use to program. And let's also go through the different processes that are like, okay, so how many of you are able to get through the things that I have discussed now? Any doubts in that? Because I will be covering a lot more in this session. Any doubts so far? Okay, fine. I can continue. Okay. And then I'll go a little into the different processes that you usually do while writing code, workflow. So how will you usually write code? So initializing a project or setting up. So this involves choosing an IDE, development environment, and that's it. And like dev tools, and also choosing the IDE, dev tools, and the boards that you want to development boards that you want to work with. So dev tools involve sometimes you might want to have this debuggers, uh, code generators, things like that will be there. So we'll be using those kind of things. Yeah. So this is like setting up, choosing all these things, the IDE, development tools, development boards, and setting up the basic structure of the project. Structure of the project can differ differently from time to time because like depending upon the complexity of your project, your structure will differ. And also it depends upon the libraries and frameworks that you select for choosing the project, right? So this kind of actually chosen when you choose all these stuff. The development both the structure is kind of mostly chosen by them itself. Then what do? You write your code, and then you compile and verify the code. So verifying the code is some like same as compiling. Just compile and checking if there are any other errors present in the code, right? And then you can either do upload to a development board or uh, you can use simulators like what we to test the code. So these are the things that you will be doing. So in more professional setups, there are like simulators that are useful for like simulating different things. So that won't be part of this code. So you will just remember the basic configurations and the workflow that we do here. So sometimes writing code involves also choosing libraries, external libraries, or the built-in libraries that you want to choose. For example, sometimes you might want to like communicate with a certain peripheral or a sensor, and there might be a library that out there, so you can just import it and use it. That also comes with it. Compilation also have like different things that you can choose between. So different compilation and upload modes are there. Compilation target, like code optimization and things like that. So in compiling, you can choose like different optimization level that you want to compile the code to. So for example, more optimized code would let take less instructions and less size in that. So there are different optimizations level that we can specify while compiling the code. So you might not need not worry about those things if you're just like starting off. But there are things like that that you will learn later in this course also. How you can efficiently write code association. And there is something there's so this uploading and debugging also can be done. Debugging your code. So while running your code, you can stop the code at the middle way and check if there are any issues or like just like debugging the C code, you can debug the code that is running in the thing. It's also something that comes in the okay. Okay. That gives you a brief intro about the things that we're working with. So in this course, we will be working with the Arduino framework and the Arduino code. So So it's not like that the Arduino framework can be only used with Arduino boards. We can also use Arduino frameworks for in the ST boards. But the thing is, with Arduino framework, you won't be able to use the full potential of the ST boards because those are more complicated. So we tend to use so when we want more customization and more control over the board, we use this HAL library. So in this code, you will be learning this basic Arduino framework. We'll start from the high level. This will be the first thing that you will be learning. And then you will be also learning this STM HAL, which is kind of little complicated over Arduino, but this can be only used with this STM boards. And then you will be also learning this area. So this is kind of a low level. So this low level programming in STM boards are like more tricky when compared to Arduino boards. So we won't be going deep into that. So we'll take a look at how AVR libraries work and maybe you can try out codes with bare metal. The only thing that you do when you do bare metal programming is you take the definitions from here and put it there. So like this is very close to bare metal. It's just a very minimal library that you can use for this. Okay. So let's start from the higher level. We'll start set up a simple project in Walkme, and I'll walk you through the different steps and how you can do the simulation. So now we'll do the hello world of embedded system, which is like building an LED. Let's start with the simple Arduino project. So you go here and create a new Arduino Uno project. So Arduino Uno is the basic development board that most people use for doing. So let's take out the structure of this project. So there is something called a sketch.ino. So this main, so it's like sketch.ino is the like the main.c file in an Arduino framework based project. And this, so now we are going into Arduino framework. My screen is kind of okay on size and all. We are now going into the Arduino framework. So there is sketch.ino. It's the equivalent of main.c. So basically, sketch.ino is also a C file, but what you have here is two functions that are it. So what's the difference? So in a main.c, you will have a main function, but in what we you have two functions which are like setup and loop. So what are these two functions that we have? So so in the setup function, so like in general C programming, the main function gets called first, right? So similarly, what will happen is this setup function will get called first, and it runs once, and this loop function will run thereafter, like continuously. So this Arduino IDE or this framework converts this function into something like this. So to give you an code-based example, you have something like this h.ino. Uh, just have something like this. So this is your code that you will see in this h.ino, right? Similarly, uh, this can be translated to a main.c file by putting things like this. So you have this main function, right? So main function will be like this. The setup will be called as in this main function like this. So you can define it there itself. So assume this will be defined before that, and this main function will have something like this setup. We are calling the setup once, and then you can have a while one loop, which is an infinite loop, and the loop function will be called it. So basically, what Arduino IDE does is like translates this whatever you write here and put it add this main block where the setup is called once and the loop is called again and again. And also it sometimes adds a header file for including this Arduino.h library with the different functions that you will be using in Arduino while writing Arduino code. So the Arduino IDE itself translates this whatever you write in setup and root to something like this. So it just prefixes this header file setup. So this is like not exactly what happens. So kind of to give you an idea of what happens. All right. Uh, okay. This is like how it happens. So it adds. So these are the things from. And it's like add. Like, okay. So the YouTube channel link, I guess, uh, let me check here. I think the easier channel link. Can find the live streams there and the previous year live streams also. So this is kind of the thing that happens where you compile a sketch.imo. Okay. So let's see what are the usual things that we need to do here. So let's take an LED and we are going to do the hello world. So these pins here, digital pins as it mentioned. So these are like the GPIO pins or general purpose input output pins, which are digital pins, which can be either set to high or low. So these pins can be either set to high or low by the code that we write, right? So high means like high voltage, so current will go through that, and low means like no current, low voltage. So you can think that of like that. So we connect this LED to ground, and this one to the positive pin, and we have our LED here. Then this is the hello world. So what should we do in the setup? So in the setup, we configure the peripheral. So there are different operating modes for this GPIO pin, and depending upon the peripherals and the communication method we are using, it will change. The initializations will change. So now, how to initialize this? So we have a function called pin mode. This function is used to configure the pin mode. There are like in Arduino, there are Arduino boards. There are three modes: input, output, and input pull-up. So for here, since it's an output device, LED voltage goes out, so it should be set in. Uh, so we should set the pin number also. So the pin number that we have connected is in 30. We use the pin number and we use output mode because it's an output device. This is the configuration that we know. So this will be run once. And then so there is this function called digital write. So digital write helps us to write a digital signal on a certain pin. So you can write the pin number and set either high or low. I am choosing high. And then there is this delay function. The delay function is like it internally runs a for loop or something like that. Like it keeps it busy waiting for a certain number of amount of time. You can mention that time in milliseconds. So 1000 milliseconds is equal to like 1 second. So what I'm trying to do is I'm making it high and waiting in the same state for 1 second, and then I am making it low and waiting in that state for 1 second. So after I go high, wait for 1 second, so the LED will be turned on high for that 1 second. And then I go low and the LED will be turned off for 1 second. And after that, this will run again. This loop function will run again. And then what you have is it goes high again and wait for 1 second and goes low. So start a simulation, you can do this. And also let's talk something about yeah, here. And also this code editor and the special files. So there is this diagram.json and this library text. These two files will be there, like the special files that you will see in an project. So you can see this diagram.json, right? So this describes what are the parts that you have here, and basically describes this diagram in some structured JSON format. So this represents what's the position of that particular code and like some things about some attributes about this. You can see the light is blinking. So we are running the code. So it compiles everything and does the simulation for. You can see the simulation running. Okay. So this is the diagram.json. Things like that. And then you have this library manager. So you can add libraries like this. For example, uh, so if I am adding this library like this, you will see this libraries.txt coming in, which will have basically the name of the library that is used here. So these are like external code that you have. You can go to the documentation also of that particular library if you want to use it. And you can see the information about that particular library. You can actually see the source code of that library also if you want to use. So it has this examples, the source code of that actual library, how it is designed. You can take a look at those things. If you want to design your own library yourself, you can see how low level, what kind of low level code that they have used for creating this particular library. So this in WASP project, you have these two special files, the diagram.json describing the diagram and also the libraries.txt describing the list of libraries involved. So if you have used Python before, you will have something similar like this called the requirements.txt, which mentions the external dependencies that this particular project might want. So this libraries.txt is similar to that in WASP. Right? So diagram.json and libraries.txt don't have any significance out of WASP. just purely for this walkthrough simulator. It won't be present in normal projects, normal embedded systems projects. It's only specific for walkthrough. So you can save and create and share different projects like setups like this, and you can easily share it with other people. Okay, so any doubts in this code or what I have explained so far in walkthrough? Okay, okay, shall we move on? Okay, so this is the first thing that you might want to do. Okay, so if you have a local development board, you can what you can do is you can try installing this Arduino IDE. There is something called as Arduino IDE, so you can install that and try running code in that. So try to install this version 2 of this Arduino IDE. I think by default you will be getting the version 2 point something only. You can download that and try using that. And then you have this STM IDE. So if you have ST microcontroller code locally, you can also try programming this in STM IDE. We call that STM Cube IDE. So for downloading this, you need to create an STM account and download this. Okay. So for this course, mostly I will be using this walkthrough simulator only, so that everyone can practice the code here itself. It's not like that you can only write Arduino code here. You can also write main.c and we'll look into it. We'll also use AVR library here to write to boost our code like the later weeks. So in the initial weeks, I'll be giving you a basic understanding of different peripherals, different interaction modes, and things like that. Uh, so the initial weeks it will be mostly so we'll be covering the higher level concepts using the Arduino code, and then we dive deeper into the low level concepts. So for Arduino, to learn Arduino programming, you need to learn the basic functions that are defined in this Arduino.h. So basically, the function, pin mode, and everything are defined in this Arduino.h file only. All those functions that you have in the header files, this pin mode, digital drive delay, these functions are divided in defined in that Arduino library. So how do we get to know what functions do we need to use? We get that from the dot. Uh, So you see this Arduino language reference is a page where you can see the different functions and structure of this Arduino code that you will work on, right? So these are the different functions. Digital IO. For digital IO means digital input output. So there you have this key function, pin mode, write and read, and then there are some math functions which you can use, some bit specific functions, and analog functions trigonometry and interrupts. You will see what interrupts is in later weeks. I'll go for that. So this is like external interrupts, these are general interrupts. Uh, this is like advanced IO. This is like generating some noise, pulsing, and things like that. For mostly used for buzzers and all those kind of buzzering input-output operations. And then there are like some printable character-specific operations, some random numbers, time-specific. These functions are like actually useful when you want to control the flow of the program, introducing delays and checking the time elapsed between two operations. So we'll be using these things over often, delay and list, and there are different ways of programming in that also. And then we'll be learning about these also different communication protocols. So there is this SPI, serial is something we look at, and then wire. So wire is like I2C communication protocol. That is what this wire sub library inside that. And the serial is a library that is for this UART based communication. The technical name for that is UART, and the technical name for this is like the I2C communication protocol. And there is this SPI communication protocol. This also we will be seeing in the later weeks. So this will give you a basic idea of what that is. And these are certain constants, things that you see in that, so the types that are available and things like that. The structure, you see there is a loop and the setup code. And these are the basic things that you will see in a C program things are basically C programming construct and structure, so you don't have too much worry about these things. Okay, so these are the main things. So you will be, if you know C, the only thing that you will be learning in addition to that is what these functions do. And there are like good ways to learn. When you go click inside a function, it will have the what this function parameters, what it returns, and an example code using that function so that you get to know how to use that function with some examples. That was a good thing to do. You can also see this different tutorials, copy paste into Workday and try out these tutorials in Workday itself. So that I advise you to go through all these basic things to get you an idea of. So in the later weeks, we'll be also sharing you some practice programming assessments. So that we will have provided solutions for, so you can learn from that. And then in around week 6 or 7, you will be having this graded programming assessments based on the practice ones, where you will be solving your problem by one and then something the solutions. Okay. Yeah. I hope that is kind of lot to take in for today. So if you want me to like explain anything about what I have, anything more about what I have discussed so far, you can ask, or you can elaborate a bit detail on what we do, what we will do with that things, what you can expect in this course and things like that. So is there anything that you want to know? And also there is like there's a lot of resources that are available. So in Workday, when you click a particular peripheral, when you use a select a component, and you can see this small uh, question mark popping up. So, so this is like function based. So you select a function and there is an example for using that function, right? In what you have like references about the components. What are the different things of the component? What are the things that you can change with the component and things like that? And then how that component works and examples with that component. So what we docs give you component specific examples, whereas this Arduino language reference give you function based examples. So these two are a good starting point to go through. And also, if you go to an Walkly example, it directly takes you to the Walkly project, which you can directly experiment on, right? So that's something that you can uh, look into. So you can create a new component, take a new component, do the configuration, and see how this configuration affects this file. You can see these attributes, color, purple is changing like that. So whatever color I give here, it changes like that. See this? Maybe I think I can do some other color also. Do black. You can see it turn to black, white, uh, pink. I think it will support any HTML specific colors that you might want to give. Uh, or I think you can use color code, hex codes for doing that, like some gray, some bluish gray, some kind of blue, things like that. You can try out with that also, like matching up that diagram.json directly. You can see how this components work. So this is what attributes that are like mentioned here. You can see the different attributes, right? So this label attribute you can add a label to a particular light. Maybe I can solve this. I'll give a label and you can see this label being displayed here. Does it have something called as label position? I don't think. That is pretty much. Uh, and the light color also maybe you can give things like that. Light color. So currently the light color I guess is white. something like white is the light color, I guess. I can change the light color so it changes to some other color. But that is not very nice, I guess. So this is fine. Okay. So you can modify the components also by looking at whatever. So these component modifications are like related to WASI and simulation setup. But in real world, we will buy these components directly as it is, and there won't be much of modification or choices that you will have in real components. Okay. WASI gives you a safe space to work with the components easily, right? So anything else you want me to discuss about or elaborate on from what I have seen so far? Arduino board only use in this course. No, we will also use STM boards, right? Some exercises will also use STM boards. Though the thing is that STM don't have a much uh, better support for simulation in this WASI. It has like simple support, but some components like the timers and other things don't have like much support in the simulation. Those things will be covered during the offline lab that you will have as part of this course. So in the offline lab, you will be working with real STM boards and you will be writing all-based codes and using STM IDE properly to uh, write code in the STM boards. So the lab will be mostly focused on the STM boards. In the online course, mostly Arduino boards will be used because like it has much support in this. It also has a STM board, but there is only limited support like basic GPIO functionalities and things like that. Okay. Or anything else? No, you don't need to buy components. You will be given the components here. Like we will give you components during the lab, and then we'll take that. Like that. We have the boards here in the lab, boards and other sensors that you will see. I think it's here. So here you don't have to buy anything else. Oh, okay. I think we can close it better. No? Thank you for joining. Good night. Thank you.